So in this video we're going to look at a convolution that we looked at in class, but we're going to solve it a different way. And we were convolving these two signals. A of t was a positive pulse followed by a negative pulse. So 1 between times 0 and 1, and minus 1 between 1 and 2. And we're convolving that with a signal B of t that ramps up from 0 to 1 and then ramps back down between 1 and 2. So we can say that it's t there, and here it's got a value of 2 minus t. And we want to find c of t. And by the definition of the convolution, we can flip or shift either one. I decided that I would want to have B stay still and have A flipped. Remember, that's the minus sign is the mirroring, and then shifting with t. So right off the bat, if we do that, hopefully we can pretty easily see that for t less than 0, our output is going to be 0. Right? So if I take A and I flip it over and t is less than 0, there's going to be no overlap. The multiplication of these two signals will be 0. So the integral is 0. The same thing will happen if t minus 2 is greater than 2. So if the back end of this after I flip it is greater than 2 on B of tau, the same thing will happen, right? And so that's t greater than 4. C of t will be 0. This hopefully makes sense because we know that the width of C should equal the width of A plus the width of B. So the width of A is 2, the width of B is 2, so the width of C should be 4, and so it will have value between 0 and 4. Okay, cool. So then we need to figure out what happens between there, and my suggestion is to always start with a picture so you can see what the heck is going on. And so here is B of tau and A of t minus tau. Now we're interested for values of t between 0 and 1. And so if we mirror A of t, right, to make A of minus tau and then shift it by t, we get something like this. So here's t minus 1, here's t minus 2 as it lags behind. And so our integral in this area, or this band of time, is from 0 to t is all we have to worry about, right? The product is 0 here of the two functions, and the product is 0 greater than t of the two functions. We just have to worry about 0 to t, and the integral is 1, so A of t minus tau has a value of 1, and B of tau has a value of tau. And I'll skip all the math, and that's 1/2 t squared. Alright, next we have the situation, so another picture here. Now when t is between 1 and 2, we'll have something that looks like this. So here's t minus 1. C of t now, we have a piecewise linear, actually two piecewise linear functions here, so we're going to have to break our integral up into pieces. And so from 0 to t minus 1, we have minus 1, which is the value of A of t minus tau, times tau. From t minus 1 to 1, we need to have a different integral, right? Because now A of t minus tau has a value of 1. And then finally, between 1 and t, A of t minus tau is still 1, but B of tau now has a value of 2 minus tau, d tau. So 3 different pieces because these are piecewise linear functions, right? And again, there's a whole bunch of math, and we end up with something that looks like this. Okay, next is when t is between 2 and 3. So b of tau stays the same. Here's a of t minus tau. So here, the output c of t. So here's t minus 1, here's t minus 2. So again, multiple integrals because we have piecewise linear functions. From t minus 2 to 1, a of t minus tau has a value of minus 1, b of tau has a value of tau. From 1 to t minus 1, a of t minus tau has a value of minus 1. B of tau now has a value of 2 minus tau. And then our last piece here is between t minus 1 and 2. We need to integrate a of t minus tau has a value of 1, and b of tau has a value of 2 minus tau, d tau. Do all the math. Double check because you probably added up wrong like I did a bunch of times, and you get this. Okay, one more area to check, and that is when t is between 3 and 4. So b of tau is not moving, but as we change the value of t, a of t minus tau is moving, so t is now between 3 and 4, so it's going to look something like this. So here's t minus 1, here's t minus 2, and so here's c of t. Where do we need to integrate? Well, just between t minus 2 and 2, because otherwise the product of the two functions is 0. So a of t minus tau has a value of minus 1. B of tau has a value of 2 minus tau, d tau. And I can do a bunch of math. Minus 1/2 t squared plus 4t minus 8. So there's my answer. I can organize it a little bit better, but that's the answer. I was kind of wondering if I did all the math right, and so I decided to do it in MATLAB and check my version where I did it by hand with doing the convolution command in MATLAB. So here's my two input signals, which I outlined in marker already, and the output by hand, C by hand, is exactly the same as C from MATLAB, and so if you can't see it, it's this curvy shape with four different domains really, but it's a nice smooth curve. So I did it right. I added up all my terms right. I'm very excited.